Hello and welcome to this R tutorial. I'm super excited to be in the deep learning part. This is one of the most fascinating and exciting branch of machine learning, and besides, it's one of the most powerful. In the following tutorials, we're going to solve the business problem described by Kirill at the beginning of this section, and you will see that we're going to get strong results thanks to this artificial neural network that we are about to build with R. So as usual, we're going to make this artificial neural network model very efficiently, and we're going to use the best package for that, which I will let you find out about in the next tutorials. So let's start, and the first step of our journey is the boring step, data preprocessing. But we will do it very efficiently because we have our template, our classification template that I've prepared here. And why can we use this classification template? Well, it's by nature of the business problem. You saw in the business problem description that you have some independent variables, and with these independent variables, you have to predict a dependent variable that has a binary outcome. And since the outcome of the dependent variable is binary, that means it's a categorical variable. That means we have to predict classes 0 and 1, and therefore that makes our problem a classification problem. And so, okay, we're going to build a deep learning model, but this deep learning model is going to be nothing else than a classification model. And that's why we are going to use our classification template that we have here, and that will save us a lot of time to build our artificial neural network. And besides, we want to focus on the deep learning model itself, so we will get there very quickly thanks to this template. All right, so let's take everything from this template from the top down to here, because we cannot use this section here because, this is the section to visualize the training set results and the test set results as well, but only when we have two independent variables. Because one independent variable corresponds to one dimension, and since now in the dataset of the business problem we have, I think, 10 or 11 independent variables, well then it's a little bit hard to represent something in 11 dimensions. So we won't take this, but we will definitely take everything that's above. So I'm going to copy that, and let's go back to our ANN model and paste this classification template right here. All right, and now in this template we're going to change a very few things, and of course we are going to build our artificial neural network right here in this section. Create your classifier here. We can already replace classifier here by ANN to then build the model. All right, but of course we need to make sure everything's okay in all the data preprocessing step, and that's what we're going to do right now. All right, so let's start. Let's start with the basic step, setting the right folder as a working directory. So right now I'm on my desktop, I'm going to my machine learning AZ folder, then we are in part 8, deep learning, and now section 40, artificial neural networks. Here we go. Make sure that you have the churn modeling.csv file, and if that's the case, you can click on this more button here, and then set as working directory. Great, and now let's change a few things. So first of all, let's start with this section, importing the dataset. Well, the name of the dataset is not social network ads, it's now churn modeling. All right, we are now ready to import the dataset. So let's do it right now. I'm going to select this line and execute. All right, dataset well imported. Well, we have actually 14 variables, but let's see if we include all these variables in the real dataset, the one on which we want to build our deep learning model. So let's see. I'm going to click on this dataset here to see which independent variables we include in the model. All right, so just a quick reminder, this dataset contains 10,000 observations containing some information of customers in a bank, like the surname, the credit score, geography, gender, age, and all the other informations here. And during 6 months, the bank looked for each customer if the customer stayed or left the bank within the 6 months period. And this result, whether the customer stayed or left, is given in this last column here, exited. So 1 means that the customer left the bank during the 6 months, and 0 means that the customer stayed in the bank during the 6 months. So what's important to understand now is that all these variables here, from row number to estimated salary, are the independent variables, and the last column here, exited, is the dependent variable. So right now, our goal is to make a model where we can predict this result exited here, whether the customer left or stayed in the bank, from the information contained in all these independent variables here. But the thing is that in these independent variables, some definitely don't have an impact on this dependent variable exited. And so now what we have to do is only take the independent variables that could have an impact and correlations with the decision of the customer to leave or stay in the bank. And so that's what we're going to do right now. So let's look at each of these independent variables one by one, and let's see which one we keep in our model. All right, so let's start with the first one, row number. Well, row number has definitely no impact on the dependent variable exited, so of course we will not include it. Then customer ID. Well, customer ID, that's the same. That's just an identification number. This definitely doesn't have any impact on the decision of the customer to stay or leave in the bank, so we will not include that either. Then the surname, well, that's the same. It's not because your name is Andrews that you have more chance to leave the bank than if your name is Romeo. All right, so we don't include surname either. But then we have credit score, and credit score might have an impact on the decision of the customer to stay or leave in the bank. Indeed, we can assume that customers with a low credit score are more likely to leave the bank than customers with a high credit score. So definitely, we will include credit score in our model. All right, then we have geography. Well, maybe some customers are more likely to leave the bank in one specific country, and that can be due to external factors like the economy of the country or any other factors. But yes, definitely, there might be some correlations between the countries and the decision to stay or leave the bank. So we will include that as well. Then gender, well, that's the same. Maybe men or women are more likely to stay in the bank than the other, so we need to check it out. Then age, well, that's the same, and that's even quite intuitive. We might expect that younger people are more likely to leave the bank than older people because older people have more balance and have more stability. So we include age as well. Then tenure. So tenure is for how long the customer has been in a bank. And so that's the same. We might expect that customers that have been in the bank for a long time are more likely to stay in the bank than recent customers. So yes, we'll take it. Then balance. Well, balance, of course. We might expect that this customer with this high balance has a lot more chance to stay in the bank than this customer with a zero balance. All right, then the number of products. So that's the number of banking products the customers have in the bank. And so, of course, maybe that the customers with many products in the bank are more likely to stay than customers with, for example, one product in the bank. So we'll need to check it out. That's just assumptions. That's the model that will find out about these correlations more thoroughly. But, definitely from our intuition, we need to include number of products as well. Then has credit card. Well, that's a little bit of the same as this variable. Customers that have a credit card might be more likely to stay in the bank than customers that don't have a credit card. So yes, is active member, that's the same. If a customer is active, then this customer is more likely to stay in the bank than a customer that is not active. So yes, that might be a significant independent variable. Then estimated salary. Well, that's the salary of the customer estimated by the bank, and it would make sense that customers with a high estimated salary have more chance to leave the bank than customers with a low estimated salary. All right, so that was the last independent variable of this dataset. So now we know which independent variables we include in our dataset, and that's what we're going to specify right now by updating our dataset, taking only the indexes of the independent variables we want to include in the model. So let's see what these indexes are. Okay, so indexes in R start at 1. And so basically we're taking all the independent variables from credit score up to estimated salary. So let's see, index 1, index 2, index 3, index 4. So we are taking the indexes 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. All right, so we are taking the indexes from 4 to 14, because in R, it's not like in Python when we separate a matrix of features and the dependent variable vector. We include all the variables in one data frame, and so we include the dependent variable. Great, so let's input these indexes. So we just said that we want to take the indexes from 4, so that's the index of the first independent variable, up to the index 14, which is the index of the dependent variable. And that's great. Now we can update our dataset by selecting this line and execute. Great, and now, as you can see, if I, go back to the dataset here, we have all our potentially statistically significant independent variables that might have an impact on the dependent variable exited. And so now, the first step of data preprocessing is completed. We imported correctly the dataset by choosing all the relevant independent variables. Okay, and now let's move on to the second step. The second step is encoding the target feature as factor. Well, we don't really need to do that because the dependent variable of our dataset is a categorical variable with a binary outcome, 1 or 0, and the thing to understand is that the package we're going to use is going to recognize it as a categorical variable with a binary outcome. So we actually don't need to encode this target feature exited as factor. So I'm going to remove this line, we don't need it. However, we do need to do something regarding some categorical variables. Of course, I'm talking about the two categorical independent variables we have in our dataset. And these two variables are, of course, geography and gender. So we have two problems here. So we need to do two things here for these variables. The first thing we need to do is to convert them as factors. And then we will need to do something more than we used to do when encoding our categorical variables. It's to set them as numeric. And to do this, we'll use the as.numeric function. And why do we need to do this, especially here? Well, that is just because the deep learning package that we're going to use is requiring it, and that's the only reason. It expects factors, but set as numeric factors. So let's do this. I'm going back to my ANN model, and so first we're going to change this to say that we're encoding the categorical variables as factors. All right, and now we're going to take this categorical data R file that we made in part 1 data preprocessing, because there is the code ready to encode any categorical data. So I'm going to select all this and paste it here in this second step of data preprocessing to encode the categorical variables as factors. All right, so let's do this. We just need to replace the names of the variables and then add this as.numeric function to set the factors as numeric. So let's start by replacing all the names here. Well, the first categorical variable gives the countries, but it is not called country, it is called geography. So we will replace here country by geography. Same here. And the good news is that now we don't need to change the names of the categories here, France, Spain, and Germany, because that's the same names. So that's great. And we will keep the labels 1, 2, 3. All right, that's good. And now we add this as.numeric function to set the factors as numeric. So I'm putting all these factor functions here inside the parenthesis of the as numeric function. And now I just need to align everything well. Here we go. And same for here. All right, great. And now let's do the same for the second categorical variable. So we need to replace purchased here by gender. So let's do it. Purchased replaced by gender. All right, same here, gender. And now we replace the two categories no and yes by female and male. And here we can give the labels we want. So let's, for example, take labels 1 for female and 2 for male. All right, and let's not forget to add the as.numeric function, which I remind we just do for the future deep learning package that we're going to use. So parenthesis here, and now let's align everything. Here we go. All right, great. So now everything is ready. This section is ready. That encodes, as required by the deep learning package, our categorical independent variables. All right, so I'm going to select all the section here and let's execute. All right, executed properly. Now let's have a look at the dataset to see what the variables became. Perfect. Geography was encoded in the 1, 2, and 3 categories that are numeric categories, and the gender, 1 for female and 2 for male. Great, and again, as numeric factors. Perfect, so this section is now completed, and let's move on to the next one. We can see how we're getting very efficient at this. The next one is about splitting the dataset into the training set and the test set. We need to do that because we will train our artificial neural network on the training set, and we will test its performance on the test set. So we'll do that, but let's not execute too fast. We need to replace purchased here by the name of the dependent variable, which is exited. And maybe we can change the split ratio as well, put 80% for the training set so that we have 8,000 observations to train our artificial neural network, and 2000 observations to test its performance on new observations. That is the new observations of the test set. So now that's ready. We don't have to do anything more here. The most important thing is not to forget to replace purchased by exited. And so now I'm going to select all these sections and execute. Perfect. Now we have our training set and our test set. Great. So that is the whole data set. That is our training set with 8,000 observations, and that is our test set with 2,000 observations. Perfect. Now let's go back to our ANN, and we are finally getting to the last step of data preprocessing, and that is feature scaling. So now the question is, do we need to apply feature scaling to train an artificial neural network? And the answer is yes, absolutely. That's 100% compulsory. And that is because training an artificial neural network is highly compute intensive, so there is going to be a lot of computations, and besides parallel computations, so definitely we need to apply feature scaling, and besides it is required by the package. So we will execute this, but before, let's not forget to change the indexes. These indexes 3 here were the index of the dependent variable in part 1 data preprocessing. So right now we just need to replace this index 3 here by our new index of the dependent variable. And so what is this index? That is the index of the exited column. Well, we can see that directly here. This data set has 11 variables, so that means that the exited column here has index 11. So let's replace 3 here by 11, then here as well, 11, 11, and 11. Great, and now the feature scaling section is ready, so let's select the whole section and execute. Great, and now if we have a look at our training set, wow, well, yes, definitely, everything is scaled, and our test set, same, everything is definitely scaled. We are happy, we are ready to build our artificial neural network. And that's what we're going to do in the next tutorial. So I'm super excited to start. I look forward to seeing you there. And until then, enjoy machine learning.